Hey everybody, we are going to jump into finding rational zeros today in section 6. Make sure that you're taking notes for this in your notebook. Label the top. And when we're talking about rational zeros, this root word of rational is ratio, or in other words, a type of fraction. So something that's rational can be written in the type of form of a over b. So we're finding rational zeros. So we're not talking about zeros with, never-ending decimals. We're talking about something that's either an integer or it can be written as a fraction. So we're not talking about finding these type of zeros. We're talking about finding zeros that if I were to graph, let's say this is my graph of f of x, we're looking for the values of x where it hits the x-axis. So where is this value for x and where is this value for x where it hits the x-axis? Okay, so with that said, what is a zero? So just like I said, it's the value of x where the graph hits the x-axis. We can call those the x-intercept is another way of saying zero. We can call it a root is another way of saying zero, or we can call it a solution. All four of those words are synonymous: zero, x-intercept, root, and solution. You can see all of those and they mean the same thing. It also means where f of x is equal to 0. So we see it equal to 0 here and here. So if we are looking for a 0, x-intercept, root, or solution, we can just set the f of x equal to 0. Okay? So before, last section, we used synthetic division to factor out and find zeros. Okay, so we used synthetic division to either factor out a factor or find a zero. And to find a zero, we can use something called the rational zero theorem to find the list of possible rational zeros. So all the rational zeros will be listed, but they're also just possible. So meaning some of them won't be zeros, but the zeros will definitely be in this list. And here's what this means. So the rational root theorem says this: if f of x equals some coefficient on the leading term, we call that a sub n, on the biggest term, plus some values in the middle, plus this coefficient on the linear term, plus this constant term, a sub 0. It has an integer, they have integer coefficients, meaning they have some real number. Then every rational zero of f has the following form. So if this is the rational root theorem or rational zero theorem, we're going to look at the number or the coefficient on the leading term. So the factors of this number, we call those q. Okay, so we're going to call that q. And they're the factors of the leading coefficient a sub n. And then this value back here is that constant term. So we say P is the list of all the factors of the constant term a sub 0. Okay, so we're going to see this practically. How do we use this? So for this example number 1, we're going to list the possible factors of f of x. Actually, I'm going to of f of x, and we're going to say, okay, in order to list the possible factors of this function member, we're going to use the rational zero theorem. Okay, so first we're going to come in here and we're going to identify this is our q right here, and this is our p right here. Okay, so we're going to have to list our factors of P over the factors of Q. So the factors of 12 are 1 and 12. I kind of do them in pairs. 2 and 6, and we say plus or minus 6 because it could be positive times positive or negative times negative. plus or minus 3, and plus or minus 4. So those are all of our lists for 12. And then to find the factors of 2, we say this is plus or minus 1 and plus or minus 2. So our possible roots are every value of P over every value of Q. So here's what we're going to do. We're going to take every value of P, so 1, 2, 3, 4, 6, 12, and put it over 1. So 1 over 1 is just 1, 2 over 1 is 2, 3 over 1 is 3, and you kind of get the idea. It's going to be the same number. And then we're going to take those same values and put them over the second value of Q, which is 1 over 2, 2 over 2, 3 over 2, and so on. So we're going to go 1 over 2. 2 over 2 is just 1, and it's already listed. 3 over 2. 4 over 2 is 2, which is already listed. 6 over 2 is 3, which is already listed. And 12 over 2 is 6, which is also already listed. So this is our total list of all of our possible rational zeros. Okay, and that's all we had to do. We just had to list them. Okay, so now we're gonna see, once we've got our list, we can continue to use synthetic division like we've been learning as a fast and easy way to test the possible zeros. Remember, so we're gonna test these possible zeros to find real zeros. If the remainder is 0, then the value being tested is a 0. So we're going to choose all these values or some of these values from our possible list to find our zeros. Now keep in mind, here's a big hint. Okay, everybody look. Highlighting in 0, the biggest exponent tells us the number of zeros that we need to find. Okay, so because this degree here is 3, I know this one has 3 zeros. Okay, so if we're going to find all real zeros of this, we're going to first use the rational root theorem to list all the rational roots. So here we go. We're going to, remember, we call this is our value of P, and this coefficient here is our value of Q. So we list our values of P for the factors, and we say, okay, plus or minus the factors of 20. So here we go, 1 and 20, 2 and 10, 4 and 5. And then our factors of Q are just plus or minus 1. So our possible factors, P over Q, means every value of P I'm going to put over every value of Q, which is just all of our list of P factors over 1. So it's going to be the same thing. 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 5 over 1 is 5, 10 over 1 is 10, and 20 over 1 is 20. So there's our list of possible roots. Now that we have our possible roots, now we're using our graphing calculator. Instead of, well, now here's the thing. I'm giving you this as a tool to cut this down. Or you could check every 1, 2, 3, 4, 5, 6 times 2 plus or minus roots. That's possible 12 that you would have to check. So instead of making you do synthetic division up to 12 times, I'm going to let you use your graphing calculator and choose a reasonable value to start. So as your starting point. Okay, so we're going to use our graphing calculator to do that. So for me, I'm going to just show you what I'm graphing right now. I'm going to graph in my graphing calculator y equals, and we're kind of backing up, y equals x cubed minus 8x squared plus 11x plus 20, because that's the function that we're coming from. And when I hit graph, the graph looks, I'm just going to kind of show you what it looks like. It looks something like this. And I'm just going to give you an approximate graph. and it looks like this. So I'm going to use one of these approximate zeros as kind of my starting point, and I'm just going to choose this first one to the left. I'm going to try x equals -1, okay? So that's what I'm going to do. So again, -1 is still in my list of possible roots, and I'm going to use synthetic division to try it. So here we go. I'm going to plug in -1 here. And then using synthetic division, I'm coming up here and I'm looking at those coefficients of my function. So it's 1, -8, 11, and 20. Again, going in descending order, no missing terms. So 1, -8, 11, and 20. We write those coefficients down, leave a space, and now we're going to use synthetic division to test this to see if this is a 0. So again, bring down the 1. We multiply the bottom row times the box. So the bottom times the box gives me the next number. And then we add down, which is -9. Again, we multiply bottom number times the box gives me the next number, which is +9. Add down. And we multiply the bottom times the box. Whoops, this isn't going to work for us, is it? So even though it looked like it was probably 1 on my graph, it's not 1 because it's not a 0. So this is not a root. So let's try the next one. Let's try 4 because it looks like it probably was 1. So we're going to put 4 in the box, and I'm going to use these same coefficients. Okay, let's try this. So we're going to go 1 times 4 is 4. -8 plus 4 is adding down. We get -4. Multiply. Add down. We get -5. Multiply again. -20. And look at that. Our remainder is 0, which means that this value of x equals 4 is a 0. Check. Okay. And remember how I said our remainders give us the constant x and x squared values. So we're left with x squared minus 4x minus 5. We still need to find the rest of the zeros. But since this is a quadratic, don't we have a way to directly find it instead of having to test all those values? Once we have this in quadratic form, now we can use the quadratic formula. All right, so let's do it. So we've got our A, B, and C values, 1, -4, and -5. We go x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to simplify that. We get 4 plus or minus the root of 16 plus 20 over 2. We get 4 plus or minus the root of 36 over 2, which that's beautiful because the root of 36 is really 6. So 4 plus 6 is 10 over 2, and 4 minus 6 is -2 over 2. And we're left with 5 and -1. So our zeros, we found the first one that worked. That's right here at 4. Uh-oh. So we found the other one that was a 4, with synthetic division. And then we solved the rest with a quadratic, and we got 5 and -1. And those are our zeros. All right, everybody, I'll see you back in